All right, now that we've reviewed oxidation states, we can talk about balancing oxidation reduction reactions. So in order to balance a redox reaction, we typically split it into two half reactions, one involving just the reduction, one involving just the oxidation. So the oxidation half reaction will have electrons as products because we're losing those electrons. The reduction half reaction will have electrons as reactants. So I have a sample reaction here where the oxidation reaction, the iodine being reduced to iodate plus 6 electrons. You can see iodine goes from a -1 to a +5. And then the reduction reaction, chlorine plus 2 electrons goes to 2 chlorides. And then you'll notice that the overall reaction has different coefficients than the half reactions. That's because we're going to use our half reactions to balance, so that we're balanced not only with atoms, but also by charge. Okay, so how do we balance redox reactions using the half reaction method? So we're breaking our reaction down into two half reactions. They will both include electrons. And then we'll balance each half reaction for atoms. And then balance the two half reactions against each other so that when we add them together, the electrons lost and gained will be equal and cancel out. So here's a step-by-step protocol for how to balance redox reactions. Step 1, assign oxidation states and then determine what's oxidized and reduced. Second, write oxidation and reduction half reactions, including electrons. Remember, electrons are products for oxidation. Reduction has them as reactants. Then we're going to balance the half reactions by mass. The way we'll do that is first balance things other than hydrogen and oxygen. Then everything we're going to be looking at is going to be in an aqueous reaction. So we can add water where we need oxygen, then add H plus where we need hydrogen, and then some reactions will be done in acidic solution, then you can be done with step C there. But if it's done in basic solution, we're going to neutralize our H plus with hydroxides. Then we will balance our half reactions by charge, by adjusting the electrons and coefficients. Balance electrons by half reactions, add them together, and then double check. So let's work this through using this reaction. So first step, assign oxidation states, determine what's oxidized and reduced. So that's already done for us on this slide. So we can see iron has a +2, goes to a +3, so it is oxidized, it gained oxidation state. Manganese goes from a +7 to a +2, so it is reduced. So we can separate our overall reaction into oxidation, iron 2 to iron 3, and reduction, a permanganate going to manganese 2. Next, we balance our half reactions by mass. Our iron oxidation reaction is done. Our manganese, though, we have oxygen on the left and no oxygen on our right. So we're going to need 4 oxygens. So we're going to add 4 water molecules. That added 8 hydrogens. 4 times 2 is 8. So we're going to add 8H plus to our reactant side. So now we are balanced by mass, by elements. Then we're going to balance by charge. So we're going to figure out how many electrons got transferred. So our iron 2 to iron 3 only involved 1 electron. So we just have to add 1 electron as a product. That one's pretty simple. Our manganese went from a +7 to a +2. And so if we're +2 on the products, +7 on the reactants, and we're adding -1s, we're going to be adding 5 electrons to our reactant side in order to balance out by charge. So now plus 7 minus 5 gets me a plus 2 on my reactant side, and I still have the plus 2 on my product side. Then I need to balance my electrons between my half reactions, so I'm going to have to multiply my oxidation reaction here by 5. So I have 5 electrons as products, 5 electrons as reactants. So I can multiply this by 5 and then add them together. And that leaves me with this as my final reaction. And you could set yourself up a table and check out all of the elements. And then let's work through this plus 17. So 5 times 2 is 10, negative 1, and then plus 8. So 10 plus 8 is 18, minus 1 is 17. Here we have plus 2, nothing for my water. 5 times 3 is plus 15, so that's plus 17 on that side as well. So that's how the balancing by charge went. Okay, now I would recommend pausing the video and seeing if you can work through those steps by yourself, and then I will work through it as well. So balance the following equation in acidic solution. So step 1 is assign oxidation states, figure out what is oxidized and reduced. So our iodine is a -1. Our oxygen is a -2, so that's -14 for the oxygen, needs to add up to -2. So I have -12 left over. Then there are 2 chromiums, so each chromium is a +6. Chromium on this side is a +3, and iodine is a 0. So my half reactions, my oxidation is going to be I- goes to I2, and my reduction is going to be Cr2O7, 2-. Just gonna draw my arrow over here, goes to Cr3+. Let's work balancing atoms first. For my oxidation reaction, it's very straightforward. I can just put a 2 there. Then for my reduction, I have 7 oxygens on my product side. Sorry, this is a D. On my reactant side, so I'm going to need to add 7 waters to my product side. Then with my 7 waters, I get 14 H+. So now I am balanced for atoms in both reactions. Then my oxidation reaction, I went from a -1 to a 0. So I have 2 negatives there, so I'm going to add 2 electrons. So now my charges are balanced in my oxidation reaction. For my reduction reaction, my chromium is at a +6 and it goes to a +3. Oh, I didn't finish balancing this. Hang on. So I didn't balance for my chromium. I need a 2 there because I have 2 chromiums here in my complex. Then I need to figure out how many electrons I need to add. On my product side, currently I am at a +6, so 2 times 3 is 6. On my reactant side, currently I'm at +14 minus 2 is a +12. And so I'm going to need to add 6 electrons to make it so that both sides are now at +6. All right, so now I am ready to think about adding these together. Before I do that, I need to make sure my electrons will cancel out. My oxidation reaction has 2 electrons. My reduction reaction has 6 electrons. So I'm going to need to multiply my oxidation reaction by 3. So then down below, I'm going to write my new oxidation reaction, which is going to be 6I- goes to 3I2 plus 6 electrons. Then when I add those together, my electrons will cancel out, and I will be left with Cr2O7 2 minus plus 6I minus plus 14H plus goes to 2 chromium plus 3I2 plus 7 waters. So, there you go. All right. What about if we're in basic solution? So let's work through this example in basic solution, and it will help you to see this pattern of how to balance these. So I minus -1, oxygen is a -2, that gives me -8. We need to add up to -1, so my manganese there is a +7, I2 is 0. This oxygen is still a -2, which means this manganese is a +4. Let's write our reactions. My oxidation reaction, again, is going to be I minus, goes to I2. We just did this one, so I'm just going to write the whole thing out. Remember, balance for atoms and then for charge. Then my reduction reaction, MnO4 minus. I draw my arrow way over here, MnO2. Now I have 1 manganese on each side. I have 4 oxygens on my reactants, 2 on my products. So I'm going to add 2 waters. So now I have 4 oxygens on each side. But with that comes 4 hydrogens on my product side. So I'm going to have to add 4H plus, but I'm in basic solution, which means there are no H pluses around. So I have to add to both sides 4 hydroxides. That combines these guys into 4 water. I have 2 water on this side, 4 on this side, so I'm going to get rid of these 2 and make this 2 water because I don't need water on both sides. All right, now overall on my reactant side, I'm at a -1 charge. On my product side, I'm at a -4 charge from my 4 hydroxides, which means over here I need to add 3 electrons. Because now I'm at -4 on my reactant, -4 on my product, so I have balanced for charge. Next, I need to multiply both reactions this time, because 2 and 3, so I'm going to multiply my oxidation reaction by 3. I'm going to multiply by my reduction reaction by 2. That's going to get me, I'm going to write down below here, now I have 3 times 2 is 6I minus, reacts to form 3I2 plus 6 electrons. My reduction reaction, 2 MnO4 minus plus 2 water plus, oops, not 2 water, sorry. Forgot to multiply by 2. 4 water plus 6 electrons goes to 2, that plus 8 OH minus. Then I can add all of that together, and I'm going to get 6I minus plus 2MnO4 minus plus 4H2O goes to 3I2 plus 2MnO4 plus 8 hydroxide. So 2 manganese, 6 iodine, 4 water, 3 iodine, 2 MnO2, and 8 hydroxide. One more. Balance the following equation in basic solution. So again, I would recommend pausing the video, working this through. So minus 1, minus 2, plus 6, plus 3, 0. So my oxidation, again, is going to be 2I minus goes to I2 plus 2 electrons. My reduction will be CrO4, 2 minus, leave a big space, Cr3 plus. My chromiums are balanced. I have 4 oxygens on my reduction side, or sorry, on my reactant side. So I'm going to need 4 water. Then I'm going to add 8H plus 8OH minus plus 8OH minus. So this is going to make 8 water, which is going to cut down to 4 because I'm going to get rid of those 4. Then balancing for charges, I have minus 2 on this side, plus 3 minus 8 gets me minus 5 on that side, so I'm going to be adding 3 electrons. So I will multiply this one times 3, this one times 2, getting me 6I minus goes to 3I2 plus 6 electrons, then 2 plus 8 water plus 6 electrons. 2 and 16. Sorry, that is OH. Then if I add them together, I'm going to get there we go. And there's the answer.